So the question that we will address today is to spray or not to spray fungicides. I think we don't have a rule or formula to determine whether we need to spray or not, but I think in this talk we will cover many of the aspects and factors that you need to consider in order to make an informed decision. So probably we are not going to talk very much about the efficacy of the products, of the many products that we have available in the market to apply on soybeans against diseases. So if you are interested in it, you should probably look at the Crop Protection Network. It's a great source of information for you. We all collaborate to this network, and if you just Google fungicide efficacy to control soybean diseases, you will find a PDF with this table. It's a very long table with all the commercial products that we have in the market, their active ingredients, the frag group number, and their specific efficacy against each disease that you may have in your field or you may be dealing with. So, yes.
Yeah, and as Boris mentioned, these data that are used to develop these tables, they come from university research trials across several different states. And many of those trials are funded by checkoff, maybe Illinois soybean or Kentucky soybean or other universities, but a lot of these are checkoff funded that helps generate some of that data that go into this.
So probably we should start with which diseases you may find out there in the field. So one of them is downy mildew. This is a disease that we should be able to find very easily under decent conditions for diseases. It's very common here in our area. The lesions are very characteristic of this disease. So if you look at the upper part of the leaves, you will see only chlorotic lesions. But if you look at the downside of the leaves, you will see this. Well, it's not working. Like this very characteristic silver tuft that are the spores of the pathogen, and this is why it's called downy mildew. So it's not a major yield robber here, so we usually don't recommend to spray against this disease because we will not see any impact on the yield. So have you seen this?
Yeah, this is a common disease. Usually see it a little bit later in the season. As Boris said, fungicides don't really work very well in controlling this disease. It's actually not caused by a fungus. It's actually something else we call omycetes, which would be similar to Pythium or Phytophthora. And so a lot of the fungicides don't have much efficacy for this particular disease, but it's one that we really don't worry about too much. It comes in late usually and really doesn't cause much economic loss, but it's certainly out there, and depending on the year and variety, you may see some of it.
Another disease is target spot. So this disease here, you can see the lesions are big round, dark brown lesions, sometimes with a yellow halo. And under center conditions, you will see concentric black rings, and this is why it's called target spot. So this disease is mainly in the lower part of the canopy, but if you have a susceptible variety, it can infect and colonize the middle and upper part of the canopy. But here in our area, most of the varieties are tolerant to this disease. I think, Carl, you have seen severe disease.
This is even though this disease has been around for a while, it's a little bit new to kind of this region. I moved to Kentucky in 2015 and really hadn't seen this disease before, and it kind of started showing up in Arkansas in 2016 pretty badly, and then made its way into Western Kentucky not too long after that. And I have seen it in Southern Illinois, a little bit further south than here. Where it's kind of been a problem has been very variety specific. And it seems like maybe some of those really, really bad varieties have kind of made their way out. And I'm not seeing as much of this disease anymore. As Boris mentioned, though, this pathogen that causes this, we are finding resistance to the QOI or strobilurin fungicides in Kentucky, and some other states have reported that. And there's some work, recent work I don't think it's published yet, but it looks like there's maybe some resistance to the SDHI fungicides as well. And the SDHI fungicides are the ones that were really having the most efficacy against this disease. So it'll be interesting to kind of see how this plays out. But this is one that kind of was a blip on the radar a couple of years ago, at least in Western Kentucky, but has kind of gone away as new varieties have come in.
So then we have a septoria brown spot that is very common in the fields. So the lesions have the same color, but are like smaller and probably with an irregular shape. So it's in almost every field. We can find it right after planting, but it's more common, more close to senescence. So it may cause some yield losses. So you may consider applications between R3 and R5 that may protect your yield. So here we have another pathogen that can be resistant to group 11 or QOIs. So probably it's something that we need to consider when we have to select our product.
Yeah, and this is one that generally I've sort of just overlooked it. It's not one that typically causes a lot of yield damage unless you really get some really wet seasons. And so I'm not sure how to classify this season just yet. I think it was wet for a bit, but now we've kind of dried up a little bit, so we'll kind of see how it goes. But especially later season rainfall, this pathogen kind of moves vertically up the plant, so it's splash dispersed. It creates, so you can kind of see there on the lower leaves, there'll be spores that will be formed in those lesions, and as you get rainfall, it'll splash the spores up to the next set of leaves, and so forth and so forth. And so when we've seen this more of a problem, it's when we've had a lot more rain a little bit later in the season that kind of splashes that up into the upper canopy. And once it's in the upper canopy, it might cause a little bit premature defoliation, and that's when you could see some yield loss.
Sometimes we can find it together, like in the lower canopy with the target spot. On the same leaf, you may have both diseases. We don't have like a resistant varieties, but there are some varieties that seems to be like much more susceptible to the disease than others.
Soybean on soybean, if you have any non-rotated ground, especially if you maybe no-till, this is where you might see a little bit more disease on those lower leaves at first, again, because it's splash dispersed and it's going to show up on the lowest leaves first.
Another disease is Cercospora leaf blight. So this symptom is very characteristic. So like this purple discoloration that we see on the leaves, mainly on the upper part of the canopy. This discoloration is the result of the interaction between the toxin that is producing the fungus and the sunlight. So this is why we see it mainly in the upper part of the canopy, because of this interaction, because it's more exposed to the sunlight. So this is a disease that is widespread here in Illinois. It's a seed-borne disease, so sometimes if you don't have it in your field, you may bring it with your seeds. So the yield loss will depend a lot on the variety that you are growing, as some varieties are much more susceptible to the disease than others.
So these are actually some pictures I took from Bowling Green, Kentucky, in one of my plots a few years ago. This is the worst I'd ever seen it. Really, really purple. Even the pods were very purple. And so this is how you can result into seed infection, as Boris mentioned. It can infect through the pods, and then it create the purple seed stain, which you've probably seen in the past. This is a disease that it's a little bit hard to put my finger on. It's usually not a big problem, at least in Western Kentucky, but it can show up. And this was very variety specific in that particular year. That was also a year where it kind of cooled down a little bit later in the season, and was wet as well. And so that, I don't know if that seemed to help. This fungus, the pathogen, has become a little bit more complicated, because we used to know the fungus as Cercospora cacuccii that caused this disease. But now some work out of Arkansas and LSU, and we've contributed some isolates as part of that work from Kentucky, is showing that there's actually multiple species of Cercospora that's involved here. And so that might make it a little bit more challenging in the future, as there's different species that are involved, and there is resistance to a couple of the fungicide classes that are used as well.
What is difficult with this disease is also that sometimes when we have the disease coming, we cannot notice it because after the infections, there is like an incubation period until the fungus can produce the toxin. The toxin needs to interact with the light, and then we will see the symptoms. Sometimes these infections are much earlier than when we see the symptoms at the reproductive stages. So the fungicide timing is kind of difficult, and the standard application at R3 may not provide like a good control. I think here in Illinois we are not under a massive disease pressure. So like in, I don't know, in other states like North Carolina where the disease pressure is very high and they decide to apply. So normally we don't recommend to spray against the disease here in this area. And probably that is good because we may have some resistance problems. So the last one, probably the most popular one, not because it's very common, but it's because it can be very explosive and it's destructive, is frogeye leaf spot. Here in the picture you can see the light brown lesions. Is by far the most damaging foliar disease that we have here in this part of the state. It can cause defoliation, it can attack the pods, so can be a major yield robber here in our area. It's widespread here in the state, but what really dictates if you will have the disease or not are the weather conditions plus the variety that you are growing. So if you have like wet, warm, and humid weather, it will favor the disease in the field. So if you are close to a river or you have like extended fog periods in the morning, it's something that you need to pay attention. So here we have some resistance varieties in the market. Like most of the companies will offer you like a rating for this disease, but sometimes it's not on the top list of the traits that you are looking for when you have to decide which variety you want to grow. So if you end up having a variety that is susceptible to the disease and you are in an area with the weather conditions, you need to monitor this disease because if you have it, it may impact the yield. So the standard application timing is R3. With this disease, we have huge problems with resistance to QOIs.
Yeah, the Illinois Soybean Association started the funding for the fungicide resistance monitoring back when I was with the University of Illinois. We started that project in 2008. 2010 was the first year that we started to see strobilurin or QOI resistant strains of this pathogen. We found them in Gallatin County, Illinois, and in Tennessee and in Kentucky. And we've continued, we now have funding from USB for this project that's been going for a while, actually led by Ahmad Fakouri at SIU. He leads that project. It's a multi-state project. And we're continuing to monitor for resistance to QOI fungicides, but also looking at other fungicides such as the triazoles and the SDHIs as well.
So there is another disease called Philosticta leaf spot that can cause similar lesions. We are talking about like light brown lesions with a dark brown margin. So in order to differentiate this disease from frogeye leaf spot, we can look at the lesion, and if we see these dark structures that are the pycnidia containing all the spores, we can use this characteristic to distinguish from frogeye leaf spot. Because frogeye leaf spot will have like a center, under certain conditions, right? We have a gray discoloration or a gray center. So it's important to distinguish both diseases because Philosticta is not economically important and frogeye can be destructive. So also Philosticta will show earlier in the season when compared to frogeye leaf spot. So if you are not sure, you can always send samples to our plant clinic at the university. They will process the sample, give you the right diagnosis. I think it's just $20–25 per sample. So we all know that if we have the disease and we spray fungicides at the right timing, we will have an increase in our yields, or at least we will protect our yields. So, but what happens when we don't have the disease and we still decide to apply fungicides? There is research suggesting that we may expect an increase in the yield, and this is associated with a greening effect caused by the fungicide, mainly with the QOI. So when you apply this fungicide, your green period will be extended in your crop, and that will increase or have an impact on the yield. So this is a work that was, Carl is one of the authors. They analyzed a lot of data sets from many states, trying to quantify how much was the real impact of those applications when you don't have the disease. So the trials are from many states, including Canada, many years, a total of 240 environments, with a significant amount of trial conducted here in Illinois. And all were full season soybeans, no double crops included. So the timing that they follow was always at R3 or beginning of pod, and they had different treatments with different chemical classes and their combinations.
So some of the trials that were included as part of this analysis, they were also funded by Illinois Soybean Association starting in 2005 with Dr. Wayne Peterson. If anybody remembers him, he retired around 2006 or so. And then from 2007 to about 2014 were data that I contributed. And those were trials that were conducted all over the state. At one of those years, we had 10 different locations. So Illinois was very well represented in those trials. And then Dr. Nathan Klacheski contributed some data, some in maybe 2018, some of the later years as well.
So if we look at the impact of these applications on the yield, they found that the yield difference was only 1.6 bushel per acre. Of course, there were scenarios where the increase was much higher, but on average was just only 1.6 bushel per acres. And they also observed that it was greater when they used mixtures instead of products that were only single active, that they have only single active ingredients. They also look at the probability of recovering the cost. So here we have the probability of recovering the cost and the actual cost of the fungicide program. Here, each line is the probability, and there are the different prices per bushel that we may have. So this is for all the fungicide groups together. I think, Carl, these days could be like 13 the price per bushel? Or sorry? The price per bushel today is 13?
Yeah, I think,
like
yeah, you can see the range of $7 a bushel to $16 a bushel up there. Each one of those lines represent a different marketing price for soybeans. So I think even the current prices would fall into that range. And as Boris mentioned, you know, it's almost like flipping a coin when you don't have a disease pressure. So it's about 50 to 60% probability of recovering those costs. So it does happen. You can apply a fungicide and not have disease pressure and still have a return. But the problem is we can't predict it. We don't really have a way to predict when that will happen. When there's no disease pressure. So there are some physiological things the fungicides can do that might help improve yield, but I just can't predict when that's going to happen, and it's about a 50-50 scenario if that will happen.
So here we have the same analysis, but for each chemical class or the combinations, and what they found was that there is some minor improvements when you compare the mixtures with the single active ingredients products. So if you see, for example, QOI versus QOI plus SDHI, you will see that the curves move to the upper right corner of the chart. So meaning that there is some kind of improvement when in the probability of recovering the cost when we use mixtures. They also look at the effect of the planting date. So the yield response were was greater in soybeans that were planted at normal time. Normal time was until May 21st. After that, it was considered a late planting. And they also look at the effect of the precipitations. So again, the yield response was greater with more precipitation from planting to R3. So the highlights of these studies were that the yield response was only 1.6 bushels per acre. The probability of recovering the cost is just 50–60%. The yield response will also be influenced by the planting date and by the rainfall or the precipitation that we have from planting until R3. So all this research tells us that we have limited yield benefits without the disease. Sometimes it doesn't make any sense to apply fungicide. But as Carl said, we cannot really predict that. And always there is a risk of unnecessary use of fungicides, mainly because we can increase the selection pressure for resistance, and that will ultimately impact on the efficacy of the commercial products that we have and that are controlling the disease right now.
Yes. We're going to do a little switch of who's controlling it now. So we're going to talk a little bit more about some university research trials. Some of these will be double crop soybean trials, which we haven't really talked about yet, full season soybean trials, and then some trials that were really focusing more on frogeye leaf spot. So double crop trials, these are, we've got some multi-state fungicide trials to show here, as well as some that are specific to Kentucky. So this is something we haven't published yet, but we're getting close to publishing this. This is multi-state work, so you can see the different states that are included here. A lot of data from Illinois, Kentucky, and Tennessee, and then some data from Missouri and Indiana as well. Kind of similar to the trials that Boris and I were talking about earlier, except these are focused on double crop trials. So soybeans planted into wheat stubble. From 2008 to 2021, and fungicides were applied at the R3 growth stage. Relatively low disease pressure in this, and you can see the different classes of fungicides and mixtures that we used in these trials as well. So this is broken out by chemistry class, and so this is the data from all of those different locations, different years, etc. So a lot of data went into this. You can see the untreated check all the way to the left at about 45 bushels an acre. And the highest response that we saw was about 46 bushels an acre. One thing to notice, though, is that when we statistically analyzed these data, they were not statistically different. So if you were to talk to another scientist about this or a statistician, they would say everything here is the same, even though you see some numerical differences there. So the overall average yield response when we compare the untreated to all of the fungicides was only 0.7 bushels per acre. And these charts represent the probability of breaking even. They're a little bit complicated, so I'll kind of walk you through this. Each one of those individual figures are the different chemistry classes. So we have mixtures up at the top, and then some single active ingredient fungicides at the bottom. The DMIs are the triazoles. The MBC, there's only one fungicide that we actually have in that class, and that's benzimidazole, which is, no, that's not right. Benzimidazoles are that class. The only fungicide we have is thiophanate methyl that's in that class, and that would include Topsin and some generic versions of Topsin, and there's some mixtures that contain MBCs as well. And then the QOIs are the strobilurins. And what you're really looking for is the light green. That would, if you look up at the top, the probability of breaking even, you'd get into more of about 50%, 45 to 50% in that lightest color. And you can just see that's not really happening that often from these data set at least. with spraying fungicides in double crop soybeans. Part of that might have to do with the data that Boris showed earlier, where they looked at the planting date, and as the planting date moved into being later, that's when you saw less yield response as well. So it kind of follows that. So all scenarios resulted in less than a 50% probability of recovering the cost. So in general, we saw pretty minor responses. When we saw the mixtures, we did improve our probability of recovering those costs, but again, they were still pretty low percentage of the time. So from this data set at least, under pretty low disease pressure, we haven't really seen a benefit of spraying double crop soybeans. A little bit newer data, so this is just be from Kentucky. This is funded by the Kentucky Soybean Promotion Board, where we're looking at both double crop and full season soybeans. And we're evaluating several things. We're looking at seed treatments and foliar fungicides. I'm just going to talk about the foliar fungicide component of this right now, but we've had low to moderate disease pressure. And you can see on the map where we've had our different trials. So this is looking at full season. This is our untreated in the blue versus the foliar fungicide in the black. And we saw a 5.4 bushels an acre yield response from these Kentucky data. And I'm not sure why, but when I made this slide last year, I used $12.70 per bushel as a marketing price. When you look at that, that means that spraying a fungicide in this full season soybeans would have been profitable almost 77% of the time under that grain price and fungicide price scenario. Of course, those fluctuate, and so it would probably be better to look at this over different prices. But under that scenario, it would have been profitable 77% of the time. But when we look at our double crop, we actually saw a negative 0.6 bushels an acre in our treated versus non-treated with fungicide. And that would have only been profitable about 52% of the time. So again, you're back to that flipping the coin kind of scenario with our double crop soybeans, at least from Kentucky. So Boris mentioned that frogeye leaf spot, probably the major foliar disease that we're concerned with in this region and in other regions. We've actually seen the geographical footprint of that disease really expand over the last several years. When I started at the University of Illinois, or even when I was a graduate student, if you wanted to work on frogeye leaf spot, you went down to Dixon Springs to do that. And I had a lot of work down at Dixon Springs looking at foliar fungicides and management of frogeye leaf spot. But a couple of years ago, I published a paper with some researchers from North Dakota State University on frogeye leaf spot. So that's how widespread this pathogen seems to be now in the U.S. So again, we've got some data from a lot of different states. I had a graduate student work on this a couple of years ago and do a meta-analysis on all of these different data sets. So this was across 8 states, 2012 to 2021, total of 66 trials. And these were specifically focused on frogeye leaf spot. So we tried to plant varieties that were susceptible to frogeye leaf spot. In some cases, some of those trials might have even been inoculated or even irrigated to try to increase the likelihood of frogeye leaf spot. And we made our applications at the R3 growth stage. And one of the things throughout all this, that's when we're spraying those fungicides is at R3. But I often get questions about, have you ever looked at spraying earlier? Have you ever looked at spraying later? We have. I'm just not going to show those data today. But in some years, a later application might be helpful. In some years, R3 is the perfect timing. When you kind of put all that data together, it seems like R3 tends to kind of be the best timing over all of those years. It just happens at a time when oftentimes it's before we have a lot of infection. So there might be some infection out there, but it might be before we have a lot of infection. So it allows that fungicide to actually protect against infection. And it also helps take it through a critical time period. So you're talking about, R3 is when you've got pods developing. So you've got pods developing and fungicides might still be around even when you've got seeds starting to be produced. So that's sort of why R3 tends to be good. If you go further north, and Boris will get a lot of opportunities to talk about white mold as he goes further north, that timing actually comes up a little bit earlier around R1. But down here, we don't have to worry about white mold. So this is looking at all those data. What we've got graphed out here is efficacy at the bottom. So the higher percent efficacy, that meant the better control of frogeye leaf spot. And then on the vertical axis, we've got the yield response compared to our untreated check. And we have some different products that are listed there. But what we really see, one thing that we notice is headline, which is the green one all the way down at the bottom. That's just a strobilurin fungicide. Just a QOI fungicide. Any ideas why you think that was down there so poor? Any ideas?
Resistance.
Yes, resistance. Strobilurin resistance. So we can see that our QOI fungicides, when sprayed alone, they're not going to be very effective, right? And not going to have a whole lot of yield response from those either. So all these other fungicides that you see grouped together there, those all have different active ingredients from different chemistry classes. And we kind of see a trend with the greater efficacy, their greater yield response as well. This is a breakdown of looking at high disease pressure and low disease pressure with all the different chemistry classes there. And again, kind of the take home is where we see our largest yield responses, which would be mostly those blue bars. Those blue bars are high disease pressure, okay? So that's where we're seeing things like a 10 bushel yield response is when we have high disease pressure and a product that's going to provide good efficacy. When we have low disease pressure, which would be those green bars, we're floating around, around 2 bushels per acre or so, right? So again, higher disease pressure, that's where we're going to see greater yield response. And this is similar to what I showed you earlier. This is just, we're just looking at 3 products here, but this is looking at the probability of recovering your cost, of breaking even from that fungicide application. And broken out into different products. So we have headline, Domark, and Mirvis top. But then high disease pressure and low disease pressure. So if you look at the bottom, there's a lot of red there. Red means it's less than it's somewhere between 45 and 55% probability of breaking even. Okay, that didn't happen very often when we had low disease pressure. But when you look up at the high disease pressure, whenever we have products that contain active ingredients that are still effective in controlling frogeye leaf spot, that's when we can see that we're going to make actual money from spraying fungicides. We're protecting that yield under a high disease pressure environment. One of the things that Boris mentioned when we're talking about frogeye leaf spot are variety resistance. Seed companies are pretty good about rating their varieties, providing those ratings for resistance to frogeye leaf spot. And so that can make a difference. Again, this is some work that was funded by Kentucky Soybean Board. A little bit older data. This is from 2016 to 2017, but we had a lot of different locations throughout Kentucky, as you can see there. Some of those were just in 2017, and some of those were in 2016 and 2017. And we had this under 3 different varieties. So one variety was susceptible, one was a moderately resistant variety, and one was highly resistant or resistant variety. And then we had 3 fungicide treatments and untreated. We had our QOI fungicide, which was headline, and then we had a QOI plus a triazole or DMI fungicide, which at that time was Quadris Top SBX. And what you're looking at is frogeye leaf spot severity. So what we do is we make these applications at R3, and then we come back about 4 weeks later and we evaluate the upper canopy, the leaves on the highest leaves, and we estimate the percent of the leaf area that is affected by frogeye leaf spot. So in this case, the higher the bar, that meant the more disease. You can see our 3 different varieties are susceptible all the way to your left, moderately resistant in the middle, and resistant all the way to the right. And then the different colors of bars represent the different fungicide treatments. So the untreated was the blue bar, the strobilurin fungicide was the black bar, and the gray bar was that mixture of the QOI and DMI. And because of fungicide resistance, you can see that the QI really didn't have much of an effect in controlling disease. But when we included that triazole or that DMI, that's when we saw a reduction in disease. And we saw that in the susceptible variety and the moderately resistant variety, but we did not see that in the resistant variety because there was really no disease to rate. It would look the same if we didn't spray it, or if we did spray it, there was just no disease. This is looking at the yield difference in each of those scenarios. So this would be compared to the untreated check within that specific variety. So if you look at the susceptible, we saw about almost a 10 bushel yield response when we applied that mixture, compared to less than a 2 bushel yield response when we applied just a single QOI fungicide. But then not as big a yield differences when we're looking at our varieties that had greater resistance to frogeye leaf spot. When we put some economics to this, this is looking at the net economic benefit. So again, this would be compared to the untreated check for that specific variety. So when we look at the susceptible variety, believe it or not, we were making $100 a bushel spraying that fungicide compared to not spraying that fungicide within that variety, okay? Only within that variety. When we're looking at the moderate resistant varieties, we were actually losing money when we were spraying fungicide because there was really no disease to control. And so we were just out the cost of the fungicide. So variety really makes a huge difference, especially when we're talking about frogeye leaf spot, where we can almost have night and day scenarios in resistant versus susceptible, as you can see in this picture.
But even in the resistance ones, you occasionally may see some lesions, but that doesn't mean that the disease is going to progress over time. So you may see some lesions. If it is resistant, it doesn't mean that it's completely resistant or it should be clean, entirely clean. But yeah, the resistance is the key to avoid the disease progress over the season.
Yeah, very good point. And those that might be moderately resistant, even though you might see some lesions, that means that there's less inoculum, less spores that are being made on those lesions. And so that just really slows down the disease progress over time as well. And so, but there are some scenarios where we might have varieties that are almost completely resistant, as you can see here on the right. This was from a variety trial at Murray, Kentucky, from a few years ago. And these plots were almost right next to each other, and you can see the difference that you might see among varieties there. All right, so what have we learned over all this? I think from full season soybean, that's where we've seen the most consistently positive yield responses. Also, obviously, when soybean prices are high, those applications are more likely to be profitable. So when we have good soybean prices, even a 2 bushel yield response, depending on the cost of the fungicide, you might actually make money from that, okay? So that's something to consider. From our data, through the multi-state data, as well as some additional just from Kentucky data, less likely to see those positive yield responses that would result into profitable applications. And again, with the resistant soybean varieties, less likely to observe those high yield responses. Another thing to consider, though, is even though a variety is resistant to frogeye leaf spot, it may not be resistant to target spot or to some of these other diseases. So it's always a good idea, even if you plant a resistant variety, one that you know is really highly resistant to frogeye leaf spot, that doesn't mean you ignore it. You still need to go out there and look and be sure there's not something else coming in that you might need to manage. And this is not rocket science here, but disease does play a huge role in the probability of recovering your cost in a fungicide application. So low disease pressure, it's like flipping a coin, 50% or lower. When we have high disease pressure, we're really increasing those odds of being profitable. So those are the things you have to think about. So when to consider an application, I would say full season. The other thing you have to think about is risk. We might go into a drought. We had data from 2012 included in some of those data that Boris presented. 2012 was a drought year, right? We didn't really see yield responses from a year like that, even if we planted a susceptible variety. So weather plays a huge role here. So you have to think about the weather. Moderate to higher disease risk, which would include things like wet, humid, warm weather prior to R3. Soybean on soybean, I think in Kentucky at least we're seeing more of that this year just because of the way the economics have played out. I don't know if we're seeing that in Illinois this year or not, but certainly if you have more soybean on soybean, some of these important pathogens are going to be right there, and it's more likely that they could infect. Susceptible variety and scouting is really important. I suggest going out at the early reproductive stages, somewhere between R1 and R2, and that can give you an idea of what's out there prior to making a decision at R3.
Yeah, but sometimes at R1 you may see just a few lesions, but it can be explosive. So if you have it, just consider that. It's not if you see only 1-2 lesions per leaf, and then in 10 days it can be a mess.
Yeah, that's very true. And again, that's why it's important to know your variety, right? So if you have a variety that's very susceptible, but you're only seeing a few lesions at R1, you know that there's a chance for that to really explode, as Boris said. So it's important to kind of take those observations and put it together with your knowledge about that variety as well. So ultimately, we really have to think about all of our disease management practices. We talked a little bit about fungicide resistance. We don't have a whole lot of chemistry classes to rely on here. I know you've heard the story from weed scientists, and it's the same story when we're dealing with diseases and fungal pathogens. We've kind of blown through the strobilurin. So that chemistry class is not really that effective in most of the foliar pathogens that we have now in soybean. So it's important to really think about, we don't have that many more to go through. So, and there's a risk of fungicide resistance with all the other chemistries that we have. So as a frontline defense, especially if you know that you have frogeye leaf spot, if this is a disease that has been a problem on your farm, really maybe kind of move that category up a little bit in your thinking process when you're choosing varieties, because that's an important way to manage that disease. Crop rotation, also very important. And then really more as a second line defense, not a front line defense, think about fungicide applications and think about all these things that we've talked about to help make those decisions. This really shouldn't be, I'm going to spray every acre kind of thing, a decision that you make, in May or April before you've even maybe planted some of those fields. This should be a decision that you're making as you approach that time of the year, and you put that together with all of these other risk factors that we've talked about. And with that, there's some additional resources here that you might be interested in. Boris already mentioned the fungicide efficacy guide on the crop protection network. That's there on the right. There's another publication about fungicide resistance on the crop protection network. And then iwilltakeaction.com. That's a site that's kind of dedicated to pesticide resistance. There's really a lot of information about herbicide resistance, but there's some information on there about fungicide resistance as well. So those are some places that you could go to get some more information. I really want to thank Checkoff Dollars for supporting a lot of this research, either through local state boards or through national programs or regional programs. Very important to helping fund these trials and put together these trials that we can talk about. And as Abigail said earlier, we're not selling anything, right? So this is good information. It's going to be non-biased information. So we really appreciate the checkoff funding, however it flows through to the different universities. So with that, I think we're happy to have answer any questions that you may have.
If we look at the efficacy when adding nutritional, does it affect disease occurrence? Obviously, it's going to affect yield. But when accompanied at the same time with the nutritional, is there any research that shows that would have any effect on disease occurrence?
So the question was, if you add some nutritionals in with the fungicide when you're making that application, is there any type of effect there, either positive or negative? That's not something I've looked at specifically in my program. I don't really know if I don't have any data on that, and I'm trying to think of why that might make a difference. As far as I know, it probably wouldn't really have an effect on control either way. Any thoughts about that, Boris?
Are we talking about micronutrients or? Yeah, maybe those micronutrients that may increase the defense system in the plant may have an effect, but I haven't seen any work with results about that.
Yeah. Was there a question back here? Yeah.
What's your definition of low pressure and high disease pressure?
Yeah, question about low disease pressure and high disease pressure. Goodness. So from that frogeye leaf spot paper, I'm sorry, I'd have to go back and look and see exactly how we classified that. I think it was right around a 10% severity. And so, of course, that's after you make the fungicide application and looking at the untreated check, what disease did develop, right? So it's easy to kind of look back and say, oh, this was low disease pressure, this is high disease pressure, but tougher to do that when you're trying to make that decision on applying. And so that's why you really have to think about things like how susceptible is that variety? Is this rotated or continuous soybean? Is it no-till? If it's no-till, continuous soybean, there's probably a little bit higher risk of disease pressure there. And of course the weather, that's the biggest thing. But it's not all black and white, it's a little bit gray in some areas. But I think we divided that up, right around 10% severity was kind of where we made that difference. Any other questions? Yeah.
Do you ever use insecticide with your fungicide trials?
Yeah, question about insecticides with the fungicides. Yeah, so we've certainly looked at that. What we've seen is if you don't have insect pressure, then we're not really seeing an advantage over that from our data. There was a multi-state trial that we included data from Illinois and Kentucky that was published recently. It looked kind of similar to what the data that Boris had presented, where we looked at single applications of just fungicide, the multiple application, and just an insecticide. And we didn't really see a strong, convincing reason to put in an insecticide unless there was an actual insect pest to manage. Any other questions?
What are your thoughts on FLS pressure this season?
I'm sorry, can you repeat that?
What are your thoughts on FLS pressure this season? Do you think it's going to be, high disease year? I know it's kind of early, but...
Yeah, so thoughts about frogeye leaf spot pressure for this season. Yeah, well, I can speak to Kentucky, and I'll let Boris speak to Illinois. In Kentucky, it's really going to depend. We've got some really dry areas, and we've got some areas that have been pretty wet. And I think those that have been pretty wet, especially, we have a lot of no-till in Kentucky, and we've got a lot more non-rotated acres this year. And I just think with the wetness, that's really going to get the spores going on the debris. And I think we might be running into a season where we could have high frogeye leaf spot pressure, but that's really going to be determined over the next few weeks, see what happens. If we're really hot and dry, then of course we're not going to run into anything. But I think we have kind of built ourselves up to potentially have a high foliar disease year in places that have received a lot of rainfall.
Are there any tools that you could use to predict a disease infection?
We are working on that.
Yeah. So we'll get to that. Boris, what do you think about for Illinois for disease pressure this year?
Well, I think it will depend a lot of the rains that we may get. I understand that now we are going to a dry phase, but after that we may receive a lot of rains, and that is something that may trigger, especially for the soybeans that were planted early this season. I'm seeing a lot of differences. We have some soybeans already with flowers, other ones are just B1, B2. But for those that were planted earlier, those rain may have an impact on the disease.
Yeah.
But yeah, we're working on an app. We are validating the app. It's just an app that will tell you have a high or low risk for the disease specifically in your field.
Yeah, so the second part of that question was, do we have any resources that can help us forecast these foliar diseases? And as Boris mentioned, there is work on looking at forecasting frogeye leaf spot, target spot, I think stem canker is another one, and Cercospora leaf blight. And so some of that work is being funded through the NCSRP. Some of it is being funded through a multi-regional project that would include the Southern Soybean Research Program, NCSRP, Mid-Atlantic, and maybe another region, I can't remember. But there's work we're starting to look at that. We've got spore traps out at different sites. Those are being analyzed for extracting DNA and then quantifying the amount of these different pathogens that are in there throughout the season. And then looking at weather data to help predict disease severity. And so there's an app currently that we're testing on frogeye leaf spot. It's not quite available to everybody yet. We're still testing it this year, and then hopefully it'll be available in the next couple of years. But I think that's something that we really need to help make these decisions.